Good morning. Welcome to lecture 46 and 47 on thermodynamics of materials. So today, before lecture, this was the development in the last class. There are one or two small errors. That's why I have not removed this yet. But I will remove after I specify the error. The error is here. You can easily see Cp is del Q del T at constant pressure, is dH del H del T at constant pressure, TdS, so ds dt, ds del S del T, del Pt, now del T at constant pressure. So this will be del T, please correct this. So repeat, Cp is T del S del T at constant pressure. Starting from this, okay, this is actually easy. Similarly, you consider here at the end, also I said Cb is, see if Cp is this, Cb will be ds del T at constant volume. So this is also error, del T under constant volume. This, nothing else, all are correct. Okay, so this is your ds is Cp dt by T, ds is Cp dt by T. Okay, it's fine. So this is okay for 1 mole and n moles. Please have this. So remove this. So problem 1 is over. So I will take up problem 2 today. So remove this. So assignment number 5, problem 2. Okay, problem 2. Problem 2. What is the problem? So that these are all short questions. So that for n moles of an ideal gas, in an isothermal expansion, delta G is minus W reversible. This you have to show. Next question. Next, show that. Next, are delta G and W minus W irreversible are equal to. This is second part of the question. So answers. So solution is what? First, let us see delta G for a isothermal expansion. What is delta G? You see, dG is VdP. Under isothermal condition is 0. That's fine, but it is work done will be obtained. That's the same. DTS minus SDT, no problem. D minus DTS is TDS is DQ minus DW, same. Any way you come, because they are consistent, they are internally connected. So this is the VdP or delta G integration VdP from state 1 to state 2. Quickly, V is what? nRT by P dP 1 to 2. What you are answering? Getting nRT ln P2 by P1. What is the work done? Recall W reversible. You recall this. What is W reversible? Remember nRT ln V2 by V1. nRT ln, recall, nRT ln V2 by V1. This is what? This is nothing but minus nRT ln V2 by V1. V1 by V2 and negative V2 by V1. So hence delta G is, if you take this minus W reversible, proved. Okay. So this is next part, second part. So minus delta G is equal to minus W reversible. Is it equal to minus W irreversible also? Because W irreversible, remember isothermal condition is less than. Okay. So this for expansion, but second part, we know for isothermal process, these chalks are doing actual havoc. Chalks are this place. So for an isothermal process, W reversible is greater than isothermal expansion. Okay. As expansion is greater than W irreversible. Hence delta G, which is equal to minus W reversible, is not. Hence delta G, which is equal to minus W reversible. See, it is not minus W irreversible. Is not minus W irreversible. Okay. Third problem. Problem 3. Problem 3, starting with the general formulation of the second law of thermodynamics, second law of thermodynamics, which is ds inverse greater than equal to 0, greater than spontaneity, irreversibility, equilibrium, or reversibility. This we know. So what you have to do is you have to start from this to show what you have to show, starting from this, prove that DHSP less than 0, equal to 0. Okay. When there is no, it is better when there is no non-mechanical, in absence of non-mechanical work. This is not missing in the problem. In the absence of non-mechanical work, dW prime. This is the question. Solution, answer. This short question, so answer. Answer is what? Start. Because what I said, du inverse greater than equal to start, or ds system. You remember first few lines same, always, plus ds surrounding greater than equal to 0, or ds system minus dq process. See, remember both reversible and irreversible being addressed simultaneously. So process, dq process by t surrounding greater than equal to 0. Keep on writing. ds system is ds, you know, always write ds system. Minus dq process is what? du plus dw mechanical plus plus, you know, dw prime is the non-mechanical, t surrounding greater than. This I asked you to do yourself. Did you do this?
Directly write dq process equal to dh, since degrees dimension constant.
dq process is equal to
dh.
So
Dimension constant. So we don't do du plus dw.
now you have to. It is direct. Start from the first, from the original statement of the second law. starting from this. And moreover, what you are saying, tell me, let us see, what you are saying. Now, here, tell me what. You have to prove this, tell me.
DQ plus SD, DU plus
Oh, what you write here?
you can directly like DH since it is already mentioned.
DQ is DH, I think no non-mechanical work. Otherwise not. DQ is not DH. So that you have, that I'm showing actually. That will come down to in steps. And these steps are common, each case. So all steps better, okay? So I'm not jumping into this, okay? That will certainly same, okay? It will be. dW prime T surrounding greater than. Now tell me, now apply the condition. Under constant entropy and pressure. Under constant entropy and pressure, what will happen? Tell me. See here, ds is 0 and dW mechanical is what? For which process? Pressure. Reversible, but irreversible also included here. She is constant pressure, I don't care. Reversible or irreversible, this was given. PTB when applicable. If constant pressure, irrespective of the path. And if reversible, irrespective of the processes, okay? Any process for that matter. These are the two things you have to calculate. So one of them is satisfied here, constant pressure. So applies to both reversible and, remember, these are reversible and irreversible, okay? See, you write here. You write here. Again, spontaneity, irreversibility, once more write. At the top, first line, and equals to sign, equilibrium, and reversibility. So all these things you can write always. So it continues and continues. Dw mechanical is PTB. Apply this. Then what it gets to? Okay, so tell me. This is 0. This is 0. This is 0. What this leads to? Okay, this leads to right here. Minus, right, dw plus PdV, you all said, plus dw prime by out, by T surrounding greater than means out, greater than equal to 0. Star. Can I remove these few lines? Sorry. Or star. Or minus, tell me. Minus, what is the du plus PdV means? du plus PV. Why? Under constant pressure. That's why, other is not. Plus dw prime is greater than equal to 0. Or minus du plus PV. This is minus dw goes to the other side, dw prime. Or continue. Or this is known as H. Or minus dH greater than equal to dw prime, or dH is less than equal to minus dw prime, and that is dHSP. Under constant pressure I have already applied. That is, you write this nicely. Under constant entropy pressure is less than equal to minus dw prime. This is your when non-mechanical work is present. If absent, is dHSP less than equal to 0 in absence of non-mechanical work. Okay, so that proved. Next is problem 4. This is a very interesting question. This is not so much on thermodynamics, but mathematical or graphical presentations, but it's interesting and maybe difficult also. So, by a series of, this is purely mathematics and plot. Turn this off. This book, okay. So by series of suitable plots, we follow this, how this I am using all the time, how for Maxwell, how the second order derivative, what is the name of this? Del x, your second order differential, okay, differential, derivative is okay. Second order differential, what is that? Del x, del z, del y, del x, constant y. Remember, this I use where? In Maxwell. What is this? Del 2z, del x, del y, I said. Oh, huh? This is del 2z, del x, del y. This I said, okay? But what I have to show, what does it mean graphically? How will get this thing? But plots is what? This what I'm saying, this I used in case of Maxwell relation so that this is a perfect differential. Then there I showed del square, okay, 1 day or 2 days, I don't know. Del square z, del x, del y is del square z, del y, del x. So one of them I have picked up only to show graphically what it means. Graphically. So can be obtained. So remove all these things. Problem 4. So I'm trying to do this, okay? So you follow me. Step by step. Z versus Y I'm plotting. For the value of x is x1. See, x is a constant. I am considering x is x1. Suppose this is the plot, non-linear curve, and I am taking del z, del y. Del z, del y is slope. At which point? A certain point called y is y1. At this point, for x is x1, I am picking up this slope. Okay? This slope is what? You know very well. Tell me, what is this slope? Slope is del z, del y. First of all, what value? At y is y1 and x is x1. This you have to write nicely. 1. Similarly, repeat for another z versus y. Try to understand these derivatives or writing mathematically, and so I use this. What does it physically mean? This slope. Then again see a similar curve will generate, not exactly same, because I have changed to x is another constant called x2 and generated. Again I am taking the slope, the same value of y is y1. So this will be like this. And again take the slope. So this slope will be what? This slope means what? Tell me. Del z, del y. At this side I should have written. At what? I am writing this side. This side I am writing. Okay. Slope. This is better. Slope is what? Slope is del z, del y. What value of x? This is for x is x2. Y is still 7. Same. And third curve. We will draw 3 curves. Okay. So third curves. Shall I draw here? I draw here. It is better I draw here. Z versus Y. Again solve. Similarly, curve, draw a curve. For which one now? X is x3. The nature of may be same, but okay, relative values will change. Y. Again take a slope at the same value of y is y1. Y is this one. Here and write this is. Take the slope. Very sorry. Slope. What? Tell me. Z, del y. Where it is? At x3 is same of y1. These three curves are generated. First derivative. I want to reach to second derivative. Next, this is the figure 1, figure 2, figure 3, figure 4. Okay, figure 1, figure 1, figure 2, figure 3. I have not reached yet. I have to show this one. What is the fourth? Follow with me. This is the last one. Follow. I've taken this slope. Del z del y, del z del y, del z del y. I'm plotting this. This gentleman I plot against x. I plot against x. So what I do? Plotting del z del y, that value slopes against what? What? As you see, is actually x. X can vary. And suppose still you get another type of curve. Okay. Okay. The three values you can take. For what? Y is what? This is x. What about y? In this three curves, y is a constant y1. Y is constant. So take a slope of this. If it is straight line preferably, then it is same slope. Otherwise, it will continue only. Again, third, second, third, etc. Just I am showing, generally speaking, x. So I am taking this. This is your answer. Say any value. If you straight line, then one value. Oh, sorry. It's very sorry. This slope is what? Tell me. Is plot. Oh, del z by del. What I have missed here? What I missed? Take a look. Del z del y at constant x. X is x1, x is x2, x is constant x. But that constant value changes. Constant, but that constant value changes. So del z, I see here also. See clearly. See. I take derivative of this. Derivative of this. So del z del y x means x is a constant. Yes, x is a constant. First plot, second plot, third. But that constant value changes. So I can plot against x. Constant x, but x I'm changing. But y has been fixed as y1. So constant y. Then we take a slope. Suppose it is straight line, that will be better. Otherwise, keeps changing. Again, at a certain value of x I have to give. But anyway, don't. You have got the idea? What is the slope? Tell me. And del x. Then of these, write nicely, del z, del y at constant x, of this del x under constant. This is the answer. So this is actually, next question is problem 5. Problem 5. Quickly, let us move on fast. Problem 5. Problem 5. 5 is what? How will you resolve the apparent contradiction that DGPT less than equal to 0, less than refers to irreversible, spontaneous, equal, reversible equilibrium, less than 0, while G is a state function. Can you remove these figures? While G is a state function and should be independent of the path. This state function should be independent. Should be independent of the path. of the path. Of the path. Also, for what type of system? Also, for what type of systems? For what type of systems do you apply the condition? Do you apply the condition? Apply the condition DGPT. The two parts. Two parts. First question, you see, this I discussed already, but I am actually informally I am writing you. DGPT, what the problem? So this is state property. In one case it is 0, another case less than 0, but should not change. Should be independent of path. Should be independent of the path, but reversibility is 0, irreversibility is less than 0. So how can it be? So contradiction. Another contradiction I said, I just explained. Okay. Okay, this is okay. Achha, this I said. At the end I will give you. First of all, answer this. What is it? That means you have to understand that these two things do not refer to the same state. Okay, this will follow. Well, I tell you. Short I am giving you G prime PT or GPT. So D as a writing is plotted against N. Say A plus 2B goes to 3C is the reaction. NC is changing from 0 to 3. 0 to 3. NC. If you have a plot, this type of plot you have. Minima, not symmetric. Anything can be, but asymmetric is more common. What is this? What this point it says? DGPT is 0. This is less than 0 equal to 0. This is equilibrium. And this is the point. This is the state spontaneous. Spontaneous. That means DGPT is 0 at this state. At this state. And so two different states. What is this state? This is actually here reaction is system state is, it is actually, we have to show product minus reaction DGPT actually delta G. I will show you later, may possible. This is actually, this gives you DGPT refers to delta G. So delta G is, this is delta G DGPT or DGPT DN or DGPT DN by DN refers to delta G. Okay, that means this is what? This is the slope is here. What is the meaning of this? Delta G is negative. And this is 0 is, what is the slope here? Slope delta G is, what is delta G if you ask me? Delta G is at any moment or at a given state, delta G is what, sir? Delta G is this 3GC minus GA, just rewrite GA plus 2GB. This is the product minus reactant. Product and reactant together. Follow this. What I try to mean, DGPT DN is actually exactly delta G. DGPT refers to. DGPT note, you will note here, note, where you will note, DGPT DN is delta G, exactly delta G. Slope, you plot the slope, N means NC here, N is NC here. Extent of the reaction. Is it negative? Slope is negative. Slope is 0, 0. This point is slope is positive. What is the meaning of the negative means? DGPT negative means irreverse spontaneous. This is it. So this is the referring to this state. Delta G is a state At the state, three entities have this. And as the composition changes, state changes. So we are comparing with two different states. So answers. So call it X, call it Y. So we are comparing two different states. Two different states. States, okay? That is, one is X for spontaneity, state X for spontaneity, and state Y for equilibrium. Right here, spontaneity means, right here. For which, right? For which, tell me, what is this? Delta G negative or DGPT is? DGPT is negative. DGPT negative means DGPT by DN, which is always a positive, is negative. Let's follow this. DGPT by DGPT is change, but by DN means slope. dy small change. dy is slope, finite value, large value, small value, any value. So DGPT to DN better. So when DGPT is negative means DGPT by DN is negative. So note here. Further note. When DGPT is negative, the condition of spontaneity, DGPT by DN is always positive, is negative. DN is always positive. DN is always positive. Why positive? Number of moles of C, so 0 to 3, always positive. Happy? The minimum. This is the minimum. Okay, minimum. Okay, this is not minimum. So when we are comparing two different states. It is state X for spontaneity, for which DGPT is less than DGPT less than 0, or DGPT by DN less than 0, or delta G. With any will do. These are same. DGPT negative, DGPT by DN is known as delta G. Okay, follow DGPT. Or you don't have to make so much confusion. DGPT less than 0 and state what? Y. For which? Tell me. For equilibrium. For which DGPT is what? That's it. So you guys, no surprise. Two different states, we don't have to have the same value. Since two different states involve change in state function, change in state function should be different. State function values should be different and not same, should be different. Okay, happy? This is the case. Now, in this connection, continue. This is over. Actually, it begins with this. Actually, in this context, another relevant question, another pertinent question is as follows: is what? DGPT is less than, so when non-mechanical work involved is minus dW prime. dW prime is non-mechanical work, like electrochemical work. Happy? Now here explanation is easy, because here actually the same states. Here what is the why again here again we can ask, again there is confusion. y dgpt in one case equal to minus dw prime, and in the other case, right here this is for irreversible, and right this is for reversible. In other case is less than, in the other case dgpt is less than equal to less than minus dw prime. What is the answer? It's very easy. This is easy. Here no change, does not change. This does not, here change, does not change. But we are mental block. It is our mental problem. What is this? We could not see well. We think this is changing. We think this is once equal, another less. No, this is remaining same. This side is changing. And as should be, because dw prime is a path function, non-mechanical work. So this I said. So note solution, answer, double star, give a double star. So I get this answer, I am explaining it. Answer is what? Answer is what? Here dgpt does not change. Here answering is easy. Here the answer is simple. Answer is simple and straightforward. Straightforward. I'm removing this first of all. In this context, okay? Follow this. This is the question. In this context, what is this? What is straightforward? What is this? This is dgpt on the left hand side, on the ls, does not change. As you expect, does not change with the path, with the reversible or irreversible path. But the right hand side, but dw prime, non-mechanical work, and a path function. And a path function means changes with path. And path function. And a path function, but dw prime on the right hand side changes with the process, changes with the path. This is the answer. This is the answer. For example, which process, where it is same? Follow. Can you tell me where it is giving some work equals to, exactly equals to, and then less than etc. Equals to, suppose equals to which place? Here in this diagram, you get some work here. Now here, this point is referred in both cases. Here dg negative, hence minus dw prime. So dw prime is positive. See, this is point. So, for example, state x in the figure LM side. I am giving this value. dgpt. This should be a differentiation small, is say minus 40 joule, say. Just say. Now this is minus 40 is equals to dgpt is minus dw prime, and this is also is minus 40 joule. So dw reversible is 40 joule. Work done by system. Plus means done by system. Electrochemical work. Minus 40. So minus 40. And the second case, first case. Reversible case. And the second case, irreversible case. What is this? See, here not two states, same. So it is minus 40. How much work we get? You tell me, less than 40 joules. System offers irreversible is less efficient as it, less competent as it, less worthwhile as it. So 40 no say 30 it gives. 30 it gives. So minus 40 versus minus 30. dw prime irreversible, right, is less than dw prime reversible. So 30 joule less than 40 joule. I can have explained. So minus 40 does not change. So left hand side minus 30 joule, minus 40 joule, minus 30 joule, joule. So this is dw irreversible. Irreversible minus. So dgpt is not minus. What it is? Which is what sign? Minus 40 and minus 40. Which is less? Minus 40 and minus, which is less? So minus 40 is less. It is less, more negative. Now why these are different? Why look to them? You have understood reversible isothermal work, irreversible isothermal work completely. PDB diagram. In RTL and V2 by V1, P2 into V2 minus V1. You are all set. Here, what is the answer? Quick answer. This is you will study in electrochemistry or electrometallurgy. You study this reversible cell, irreversible. But I will give you just here triple star. This will help you to appreciate why reversible work is different. How is the reversible EMF cell work done by is greater than that by, you know what is the expression? Follow me. What is the expression? For example, dg in terms of work done, reversible work. dw, you know what is this? Reversible. You know what is that? Minus is dnf Faraday is the reversible EMF of the cell. It is actually reversible EMF of the cell. F is the Faraday constant, and dn is the number of electrons. This is the reversible electrochemical. Is minus or infinite change. So always you should be able to get infinitesimal change converted into finite change in all cases, all problems. Finite or for finite change, what is this? Tell me. What is the answer? W prime integration is what? This is standard. You remember NFE. This is the reversible work. For finite change, W prime is this is reversible. So W prime finite change, W prime reversible. Now in contrast, must be get up. What is the rule? Can you guess? Reversible and irreversible. I spent so much time. Many different processes. Evaporation, reversible. In finite driving force. There is a driving force. E minus D. E minus D is E. But it is no longer E minus D is not E minus delta E. So in contrast, W prime irreversible is, I am writing for you, E minus any finite. So it is less than. So less work. Hence less work. Hence this is electrochemical work. But E minus delta, this is a finite driving force. This is what? This is also, that is a minus. What is this? This is actually E minus, tell me, DE. Finite, infinitesimal. E minus D is what? Is essentially we don't write E minus D. So this is the difference. Or delta J for this, or delta J I have given here, delta W prime, okay. or finite W prime. This is okay. W prime is this. This is one, and this is another. Follow. Follow. Reversible infinitesimally driving force. Small driving force. What is the driving force? E minus D. What is the E? E is reversible value. Cell potential. Okay. Cell potential. And what is the opposing this? Why work we are getting? Some against the opposition. What is the opposition? The opposing EMF. What is that for reversible? Just less. E minus D, and that high value against that high value work is done. So greater work. Example, what is the opposition? Another form of what? This electrochemical cell battery. Your cell, your dry cells. This I am talking about. This reaction is here. What reaction? Not this. Zinc plus copper sulfate goes to zinc sulfate plus copper. It's the same. What is the answer? E value. You know what is the value for dry cells? You don't know. For this value, 1.5 volts. Small or large? 1.5 volts. You check this. 1.15 why 1.5 volt. If big, does not matter. So 1.5 volt. Okay. So this gives against you. So this part is over. Okay. This is total. So I will actually. This is typically problem 6. Follow this. Okay. So another application of this, that battery is used against what? With the help of you can oppose. With the help of you can oppose. So cell has a E potential oppose, so that against the opposition work will be done by the system. What is the opposition? E minus D. By the what is this called? Potentiometer. After opposition, and when it is exactly E, there is called null point. Null point. Just E minus D, then it is forward. But E minus D is not possible. What is the other way of opposing force? Electrolysis. They are carrying out an electrolysis with the cell. What are electrolysis? Sodium chloride electrolysis. That is also opposite. Against that opposition, cell is performing work by system. Positive. These are the all things. But refers to this state. Refers to this state. Can you tell me what is the E value I have given here? What is the E value here? Guess from here. Discussion. Or this state. This can be this state. Can be this state. This state. What is the value of E? 0. Why? Delta G is minus NAP. After 0, when it is 0 means what has happened? That cell has been, battery has been flat. So no, sir, no potential left. So throw away or recharge. Recharge. This is the case when it is battery goes flat, and this is in full energy. Okay. Over. Problem next is what? Okay, so I have covered both problems. Problem by me extensively I have covered because very conceptual. Very conceptual, okay? So unless you understand, then you will simply you have blindly use this constant and all these things. Likewise, the graphical presentation is also very interesting, very important to understand. 6. Now these 4 problems that I have given you in 2, in A and B. Remember, these actually millions of problems can be generated. So you may expect actually this type of problem. Follow. What are the weapons I tell you? To show that dCp by dP at constant temperature is minus T del square V dt square. This is the only questions under constant pressure. Start. Don't waste time. Okay. Millions of problems can be manufactured this way. So try to solve how I am solving. Follow. So Cp is what? I tell you. Tell me. Cp del Q del T at constant pressure. Acha. Wait a bit. Tell me. Then dH TdS. Na? Dq at constant pressure. Then it becomes TdS. So. Just groundwork. You know this, but systematically. T del S del T at a number of times. Cp. Let's start. Del Cp. What is the meaning of this? Cp is derivative. And rate of change of that Cp with pressure under constant temperature. That is the idea. How it changes with P. So del Cp by del P at constant temperature. Mathematically you can do, but physically understand. So what become dDP? Tell me, T del S del T at constant pressure. Give a second, third bracket perhaps. dDP Cp, copy Cp here, dDP under constant temperature. See, complete. See, dDP Cp, Cp under constant temperature. Correctly, I have done this. Okay, what is this? T can be outside. T can be outside perhaps, na? Okay, T can be outside. T outside? Why? A constant temperature? This is under constant temperature. T outside. See, follow, understand? Meaningless. Otherwise, meaningless. Follow with me. I am giving you the linking. Okay? T. Del square, what it is? Can you tell me what is? What is it? It is known as one step equal to del P del T. This is also equally known as what? Tell me, del square Z, del Y del X. Is tell me del T del P. Same. What then? How you write this? It just change this. How will you change? I tell you. Taking this dt outside, it is what? Del S. What is del S del T at constant pressure? Del S del P at constant temperature. And T dt of this under constant pressure. Check it. Take a look. I am very sorry. Under constant or constant. Check it. Take a look. What I am doing? Follow me. T out. Follow here. Last day from Maxwell. This was this. This is how to get it. dDP del S del T exchange. ddt P with T del T del dt del T ds del P constant temperature, constant pressure. That's like that. This will result what? Del square X del T del P. That one. So this is already, this I have used already. Z is a function of X. Ask us. Element diagram. Maxwell relation origin. Okay. This you can exchange this. Why you are doing this, sir? Why you are doing? Then yes, why I am doing this? Something is here. Something in the blackboard. And look at this. Always I is here. You cannot blindly fool around. Why I am doing this? Yes. Why I am doing this? Suddenly what interest? There is no, I have no interest. I will go back there. What shall I do? I will go back. I will rather go back here. Just change. There is del P. Is it magical? Anything magical? Shown in the blackboard. Shown in the board already. What is that? Maxwell. I said these two are very important, often used. I said others are of academic interest, or this type of academic exercise you will get. But practical use I already showed, from which what is the effect of pressure on entropy yesterday under isothermal condition, which is minus alpha V. I said practical. This was also used in the case of Cp minus Cv is Tb alpha square beta. So see how often it comes. So why not grab this? So it is T. Write this nicely. As you see, dsdp is nothing but give a minus sign, perhaps minus sign outside. Del V's are del T, third bracket, del V, del T at constant pressure. You give this, del V at constant pressure, give the says this, and what is this? Pressure. Follow this. See, del S, del P at constant pressure here, and outside there is a pressure. What is this? Tell me. Del T of del V del T under constant pressure is varying with T under constant pressure. This gentleman is varying with T under constant pressure. So what is this? Nothing but del square V, del T square, and that's it. Proved. One stroke. Proved. See? Happy to? Okay. Math. Second, B. So that. Next one, quickly. 6, this is 1. 6 what it is? 6, 1 it is. A, B. C, A 1. This is 1. A 2. A second. A 2. So that, what is to be shown? Tell me. Minus. What is to be shown? You don't know what is to be shown? You don't know? I know. What is this? What is this? Very sorry. Del P by perhaps this is perhaps given. Let us take a look. Do you have the problem? Del P by del V at constant entropy. Exactly so. Del P by del V, this must be given. Del P by del V at constant entropy is what you have to solve? Minus Cp by Cv b v beta. So that this is the second problem. Now which side you will attack? So you have to be intelligent. You will not attack this side. But nothing you can do. This is easy. Cp, Cb may cancel something. So start with the right hand side. So proceed. Right hand side. Cp minus you can give this, okay, minus Cp by Cv b beta. Just follow me. What is Cp? A moment ago it's done. Cp is what? Tell me. Cp is what? A moment ago Cp T ds, T del S del T. A moment ago Cp is dq dt at constant, dq is dh T ds. And it's okay. Similarly, can you tell me Cb? Tell me similarly. Not only always you get Cp, Cb also get. Cb means internal energy is coming that side. Work done in a constant volume is not. Okay, what is it? dq is not dh, but dq is du. Cb under constant dq is Cb dt, and under constant pressure dq is Cb dt, which is equal to dh in constant pressure, and which is equal to du in constant volume. So there are many things, but what Cb will be similarly. I wrote in last class, similar and corrected. You didn't come. Corrected that. That is what it will be. Similarly, del S, del T, constant volume. So you try. I'm telling you, one line. Cb. Stop. All this stop. Cb. No, free. Mind here. Cb is what? Del Q, del T at constant volume. Del Q is what? Under constant volume? du. Del Q is under constant volume is the first law. du is what? Cb dt. Cb. What I'm doing? What I'm writing here? CB, start. CB here. I showed you del Q, del T at constant volume. Start. First, what is del Q under constant volume? First law, tell me. Del U. Actually, del U is fortunately written here. Del U, del T at constant U is T ds. Okay. Or you can write del U, or alternatively you can write. Suppose you don't remember all this. How many you will remember? What will be remembered? Or what time will be remembered? So du at constant volume is what? First law. Anything is brought with you, first law is always. du is what? Under constant volume dq is what? T ds. Here also du is T ds. So no problem, there are many root T del S del T at constant volume. Have I not written that? See, have I not written that? Remember this, I am not writing it. I am removing this, okay? Proceed. Achha, this part I am removing, this problem I am removing. First problem is unnecessary. So once more I write. Remove all this, start again. Minus Cp, tell me, T del S happy to? Good boy. Then what is T del S del V del T under constant volume? V. Beta is what? Minus 1 by V del V del P. Actually, I am actually explaining, that's why taking time. I can easily go through very fast. But then even after all this, you will make a mistake. Repeat. What is this? Beta del V at constant. Nothing else. What else? Nothing. Give a bracket, but you have to give a bracket here, otherwise fancy. T, B, V, beta. Okay, now what cancel? V, cancel, minus, cancel. So tidy up. Write nicely, del S del T at constant pressure. And what is del S del T at constant volume? Del V del T at constant temperature. Okay, let us do one thing. How to use this? Follow this. BPT, you will be good shape. See, your mind is where? What is the problem? The problem is this. This remove this. Unless you don't remove, then it actually troubles me. This is the problem. So write these. These have to be constant ASO, PBS. Let us see. See how to solve. I can get it solved, but you will get a new problem. What you will do? See dB dpt. You have some dpt. You have a transformation. You can bring some P here. T can be changed to P by some arrangement of terms. P and this way I can do something. This can be absorbed. So this is your higher secondary. This is a constant P, another constant P, you can divide simply. This you know, very easy. This is not transformation. Under constant P and under constant P. You can always, I am doing this, you can follow. Start this, I am writing. Continue, right hand side, continue. Is what? Right. Del S del T, follow with me. Constant pressure. First term on the right, denominator intact. Del S by del T, don't touch this. Why you don't touch? You badly need a S in the expression. So don't touch. Although it is not constant, but it will come easily constant by transformation. Later on, just hope for the best. You should be expectant. Perhaps you think so. Next is what? There will be, how will you give a transformation on this? Tell me, transformation I told you, taught you yesterday. There will be, anyhow do, it will be correct. Anyhow. But follow that. I am writing. There will be by, I want a constant pressure, so I am writing, starting with this. Del B by constant, del T at constant, first thing. Follow. Del B by del P, I am writing, del T at constant pressure should be written into times here. What I can write? Tell me, del T by del P under constant by transformation formula. You have two weapons. Transformation formula, one weapon, and another is Maxwell. Follow. Now tell me, what is this? Is correct though? Okay. No, another error. Serious error. Tell me what is the error? Tell me. Del B is fantastic. But one small error. Careful. Minus. They multiply to three things. Multiply dx, dy, z. Yesterday so is minus. Transform formula right hand side is what? -1. So when you give this twist, you can write here dpt term numerator. That you can do always. Over here, that is up to you. Minus. So minus. Happy? Is correct. 100% correct. Then what will do next? Next step. See. This is your higher secondary. See what I am teaching you. This is higher secondary. These two. What it is? Tell me what is. Tell me these two. This is not thermodynamic study outcome. This is the highest dx dy z dp dt z. So it is z is constant, same is very easy. What is this? This is p. This is what is this? This division is what? Del S by del B. This is no transformation, constant pressure. Follow this. You don't know this? Oh wow. Arey del X del Y Z. Tell me. Into del Y del T Z. What is this? Both are Z, there no problem. Del X del Y or del I del cancel though. Okay. So times actually no. This is what I am telling you. Del X del Y times del Y del T, whole thing in bracket. This is the meaning of it. And this cancels in this case. So del X del T Z. Okay. This is high school or even less. I do not know when. So remove this. So unless you actually support me, then I will take time. That is another reason I am so much slow. I am writing details for one reason, no doubt. Happy to? This part is over to. How much is over? These two. What remains? Right? That you do. What remains here? Del T by del P at constant volume. Okay. Oh, this is unnecessary. This is already absorbed. Thank you so much. So can you write this on the top? Right on the top. 1 by top is better. Del P. Tell me. Constant volume and it is done. 1 by dy dx is what? 1 by dy dx. dx by dy, that I have done, okay. So shall I remove this? Shall I remove this? 1 by, done, both are volume. What it is? Oh, what it is? dp by ds at constant volume. What is the proof? I made a mistake, na? ds by dv at constant pressure. Del S by del. How did I remove that? Oh, sorry. Forget. Achha, let me write it. This line is okay though. This line is okay. Let me do again. Let me do. Don't. You don't have to. These two together. So I am teaching so I'm training so much that I myself is mixed up. This is okay though. These two gone. Then write others as there. Del S by del T at constant volume. Del T by del P at constant volume. Okay. No, wrong somewhere. Huh? Well, I made a mistake. I start over. CP by start. CP this okay? This okay. So del S del T at constant pressure, del S del T constant dp at constant temperature. Then next is what? Start. Del S del T at constant pressure. There is correct. Then this is what? This is a transformation. So dv dp at constant temperature, 100% correct. Okay. Next is what? What I am trying to do. These two are absorbed. So ds dv. So this is done. So ds dt at constant volume, dt dp at constant volume. What is it? These are two volumes. How can it be? ds dt constant. What is this? What I have written? What you have written? db dt at constant pressure is correct. Okay, let it be so. Okay. So what is being done? What is this constant volume? Then what it is? Let us see what happens. Remove this. Del S by del V. What is this? This is constant. So del S by del P. Like this. Right. Whatever happens. Like this. Del S by del P constant volume. What remains here? Del V by del T at constant pressure. Let it be so. Again what you are getting? Again constant pressure. I don't know. I am the actual. Somewhere I have screwed up. Huh? Say that's what? Which one? This one. Achha, I am stuck. Tell me here. Del S by del T at constant pressure. Okay. Del S by is okay. dv by dp is what? dv by dp is dv by dt is correct with minus sign. Next is what? Next what I am trying. Both are pressure. So these two will be. So what is this? Del S by del V under constant on the top. Then this will be there. What's the wrong? What is the wrong? This must be there. Oh. So I wrote this. So what is the problem? You stop me. Okay, this. Write this again. Minus, still minus. It's okay. Del S by, sorry. Practice. Minus, quickly. What is this? What is all, both B, so cancel. Del S by, actually cancel. Del S, how many things are here? 3 things. SVP, again Maxwell. I am very sorry, transformation. SVP. So ds dv. So ds cancel, remaining dp by dv. Tell me what is that? Tell me. As if cancel. It doesn't cancel because constants are different. dp by dv and under third one. pb means s, the third one. Minus, here is minus and this minus absorb. Proved. Unnecessary, we are wasting time. Suddenly actually. Okay. So I repeat. It just starts right hand side. Start from right hand side. These are very easy. Then next is this. This you will do. This is simply your, what is this? A transformation here. A minus I have taken. You got a minus. And this is very easy. This is high school. No Maxwell, no transformation. Then another two still remains. Can I remove? What is which problem? This is 6 or 7. 6D. 1. 2. Given, prove this. Given what? dA is minus SDT. You solve this, Z dq. dA is minus SDT plus Z dq, and Y is these are arbitrary functions. Don't have to consider entropy. Don't worry. You are not asking. Just any. You can write T. N. Y is what? Q minus A minus QZ. Quickly follow. First of all, I ask you to give transformation. Yeah, Maxwell. I'm sorry. I'm very sorry. Sometimes I'm using Maxwell. Who is Maxwell? This is differential. So tell me, what is Maxwell? Right? Del S by del Q under constant del S FC. Del S by del Q constant T back. Temperature is what? Here del Z by del T. Del Z by del T under constant Q. Of course. And minus. Similarly, you do another thing. This is what? This is right here. Maxwell. Not ready-made Maxwell. These are you manufacture now. A principle remaining same. Then what is this? dy is what? dA minus Q dz. Tell me. Minus Z dq. So now, 1, say this is 1, 2. By 1 plus 2. By 1 plus 2. What you get? Substitute this value. Substitute dA value here. dA. dy is, what is dA? Tell me, right? Minus SDT plus dq. And then minus Q dz minus Z dq. Very easy. Then cancel these two. What remains? Or dy is minus SDT minus Q dz. Happy to? Happy. Remove all these things. These are all distractions. Happy? So this is box this. Why? This is a differential, perfect differential. Perfect differential, what I said? Perfect state function. Okay? Perfect differential. And this is also, if you box this is also another perfect differential, and Maxwell can be operated. So Maxwell, we apply Maxwell here. Tell me, Mr. Tell me, what is the Maxwell? Apply Maxwell on this. This is perfect differential. Del S. At constant what? Perfect. Del S by del Z at constant temperature. Is both minus means no resulting, okay? Resultant minus, okay? Is what? This side is what? Del Q. See, I am trying to give you a solution, one of the solutions. There can be hundreds of other solutions. You try your way. Okay, no problem. Okay, so you have these two are very useful. This and this. Okay, right, call is equation 3, 4. Again give a box perhaps. Box, very important. Maxwell, and this another new Maxwell actually. Q, right, nicely. Q. Okay, quickly take up. What is to be proved? Now what is to be proved? What you are giving? First, left hand side. To prove. Left hand side is what? I tell you again, I'm right. To prove, I'm giving you del S, let me write, to prove del S by del Z Q, complete this, it will be 3 minutes, 6 minutes total. Del S by del Z Q, I'm doing all kinds of nonsense. Is what is equals to del Q by del T constant S. This you have to prove. Follow. You start. These are things given based on given Maxwell. This is given differential and manipulation, another form of perfect differential expression, Maxwell. These are available with me as weapons. I use freely. But this is to prove. How will proceed ds by dz? Or tell me what is this? Left hand side. Start. Left hand side is del S by del Z Q. Okay, take a look and be clever. Del S del Z Q. Del S S Z what you can get here? Okay. Let us do one thing. There are Q here, directly Q. Use Q by your higher secondary. Keep Q. What is that? And dt. So del S, del T. Bring in del T. And so that you get a dt. Del S del T Q divided by del Z by del T Q. This is your higher secondary. I call it higher secondary. It is so easy. Higher secondary, actually partially higher secondary. This is okay too. Now how I take help of this now? Yeah, Maxwell. To put this and one line, so what is that? Is minus from 3 actually. Minus, so tell me, del S right, del S on the top, del S del T Q. Happy? What else? Del Z del T Q is what? Nothing but minus. Tell me. Minus del S del Q T. Happy? Very easy. Write what you write here. From, right, from equation, tell me, 3. Substituted. Now what is the answer? What is this? See, what is, does it attract you? Does it anyhow attract you? What you do? See, take a look. You have to see wherever. What? Transformation. Maxwell not those. Transformation. Why? 3 things. Not 4, not 2. No 2, no 4. 3 things were there. STQ. It is a deal of STQ. So you can get easily. So what is this? As the minus cancel. And minus cancel. What is this? You will get residual minus. Na? Okay. So what it is coming is dq by del T at constant. Have I read correctly though? Minus I have given here. And what is this? Oh, there are 2 minus, none? This is wrong, na? Tell me. ds dt q. This is nothing but this with a minus sign. Why so many minus? 1 minus, Then you get a minus from transformation. So minus plus. This is the answer. Is this the answer? Oh, yeah. Proved. Right hand. This is right hand side. So there is only one left. Okay. What is this? B giving. B, this is to prove. This 1 maybe 6B1. Okay. 2. I'm writing here. 2. To prove another one. Another try. Last one. Correct. To prove. Tell me what is the to be proved? Del S del Z by del T at constant entropy minus del S by del Q at constant Z. Let us not take risk. Let us see quickly. Del Z by del T, constant entropy. Perfectly. How will you solve this? Proceed. Left hand side. Proceed. What you will do? See, what tempts you? Achha, can I remove this? Since we are doing so many Maxwells, it is better we remove them. The earlier ones. What tempts you? I clearly see. Something, this one, see? This one. So this one has link up. So I have somehow managed here. So SZT. This one. So what shall I write? I can write only one. Transform function gives only one option. What is, shall I write this? You want del S del Z. I am writing. Left hand side is del S by del S del Z T. And what it will be? Obviously del S by del T Z. Take a look. This one negative sign. Take a look. Left hand side. Take a look first. I have done for you. This color left hand side is okay. Del S cancel as if. This is as if, because these are constant are different. As if del Z by del T back and constant is negative. Is what? Tell me. Del S del T constant Z. Acha. So you want to convert it We want to convert it into somehow what? What I do? Okay, it's okay, perfectly. Oh no, I have not used. Why I did this? I will take advantage of this. So why not substitute this? Minus del s by del zt, right? The derivative is what? Minus, see, this spot should be removed. Minus. Tell me minus del q by del t constant z. This from what equation? This was equation 4. Write this 4. From equation 4 you write here. From equation 4. You are almost done. One line. What shall I write here? Tell me. As it is. I will have both are z. High school. Both are z means high school. Del s by. I've given minus here. This is no minus, na? Equal sign. Equal sign. Thank you so much. Thank you so much. Thank you so much. Okay. Now you see what is this? What is this deal? Both are z. So you put del s by del p at constant z. It is I say a negative sign. So write that. Last line you write yourself. Is I'm writing this side better. Is minus del s by del q at constant z is right hand side is proved. So how many? 4 problems we solve. You have got some idea, some comment, but there are numerous, I should say. Careful, watchful. Last problem is, last but one. How much time left can I get? 10 minutes can I get? Okay. Go, keep quiet. 10 minutes. So remove this. Make it clean set. Remove this. All remove. Just read the problem. Read the problem. While easiest. But you have to participate. These are the 2 easy problems. 2 easiest problems. But still formally I am solving them. Problems, tell me, problem. 7th, what it says, it says something. Keep it there. Using the relation, right. Using the relation, what is the relation I tell you? P1 V1 to the power gamma e to the power minus S1 by CV. Recall, tell me, is P2 V2 to the power gamma e to the power minus S2 by CV. Valid for any process. Any process with including, okay, say, including any process, what I said, constant pressure, constant temperature, and constant volume, and adiabatic no. Adiabatic is no. You know very well this is not adiabatic, reversible adiabatic, and any process and irreversible adiabatic. Okay, valid for this is the general. Okay, these all reversible or irreversible. These 3 are irreversible, same relation. Irreversible adiabatic is troublesome. This is typically called for irreversible adiabatic. Okay, and for fixed mass fixed composition system. System has a clear picture. Oh, 1 mole of ideal gas is expanding isothermally as it. So what is this? Is the relation to arrive at the relationship. Quickly answer. At the relationship P1 V1 is P2 V2. Quick. P1 V1 is P2 V2, which is for both reversible and irreversible isothermal process. For both reversible and irreversible isothermal process. Thermal processes with n moles ideal gas. Shall I proceed quickly? Proceed quickly. See, this is for how many moles? Follow me. This is S1. I told you, I explained you. It may be n moles, 4 moles. But if it is molar, then molar. So it is, if you want to make 4, it times 4 times 4. Both are intensive, make extensive, so cancel out. So it can be used for n moles also. So now, tell me, I am writing. You help me. I am taking this side. E to the power S2 minus S1 by CV is what? P1, right, nicely? P1, P2, V2 to the power gamma, T1, V1 to the power gamma. Happy? Is okay, side chain? Or ln, S2 minus S1 by CV is what? ln of this P2, V2 to the power gamma by P1, V1 to the power gamma. Okay? What is S2 minus S1 for the process under study? What is S2 minus S1? Tell me. Okay. Oh, I made a mistake. No, it's okay. It's okay. Tell me. What is S2 minus S1? RLN isothermal process. Delta S isothermal. RLN V2 by V1. CB, what is the general relationship? CBLN T2 by T1 plus RLN V2 by V1. General. So isothermal. Good boy. Okay. So since it is one molar, so any moles you don't give is molar. This is also molar. Let us see what I have done. Okay. I hope I have done that way. Okay. Right. Or tell me what is this? As you tell, what is this? ln RLN V2 by G1 by CV. By CV to CV I am writing. One stroke CV by R. I am still writing. It is CV by R to. Or right ln T2 V2 to quickly one line answer. See, make it ln. Make it ln. What is the ln? V2 by V1. Powered what? R by CV. CV by R is the below, means R by CV is the, and that goes as a power. What is R by CV? Tell me what is R by CV? CV minus CV by CV is gamma minus 1. R is, so write another line, okay? Is what? ln, like this, sorry, keep it there. ln P2, V2 to the power gamma by P1, V1 to the power gamma. Will you cancel ln? You cancel suddenly, na? You cancel suddenly. Is what? Now V2 by V1, what is R by CV, right? CP minus CV by CV is P2 V2 to the power gamma by P1 V1 to the power gamma. Okay? What you are getting here? Tell me. V2 by V1 to the power gamma minus 1 is P2 V2 to the power gamma by P1 V1 to the power gamma. Tell me. So one by one. See. Take this V2 right hand side. What is this? V2 to the gamma, and this is what? V2 to the gamma minus by gamma minus gamma plus 1 means V2 itself. Similarly, if we come to this side, it is gamma by gamma minus 1. Or whose equation is this? To develop to show that P1 is P2 V2. Shown. That is the isothermal process. What is isothermal? PV is constant. What is P1 is P2 V2? That is only for isothermal. Okay. V1 by T1 is V2 by T2 for V1 by T1 is V2 by T2. Constant volume process. V1 by T1 is P2 by P is proportional to T. Shown. Last problem is very interesting and easiest of all. Read the problem. This problem shall I am talking of this. Quit this. Let us see. Problem 8. What is the problem like? An engineer claims to this Carnot cycle. False claim. An engineer claims to have invented a cycle in which the system takes 2400 kilojoule. Takes 2400 kilojoule of heat from the source, from the hot reservoir working at of heat from the hot reservoir working at 400 K. And rejects at the most underline at the most 1800 kilojoule of heat to the cold reservoir. Working at 300 Kelvin. Give your comments on the engineer's claim. Give your comments on the engineer's claim. Quickly, this is like 1 minute. Solution. See, can you take a look? See, when it is, this is 6 ratio, this is 6 ratio, means this is actually reversible. But the problem he has made, it is the maximum, means it can be less than also. Goes to his credit, but that is a false claim. It cannot exceed reversible performance. It cannot reject less than reversible. Rejects minimum is reversible. So it can be less than rejection, reversible rejection. So answer, delta is system cycle. Cycle is how much? Since it is a cycle after all, how much it is? How much? 0. He said, I told you. So you didn't go to your, how did you give the test then? And the last day, this type of claims, three claims I analyzed. The same thing. Same problem I have given here. Just twisted the language. So what was your preparation? And yesterday exam, this is Carnot cycle 3 claims. 3 contenders came, one said this, another said this, another said this. In terms of efficiency, in terms of delta S universe, I said, comparing the reversible efficiency of the comment that you make with the second law statement, delta S universe positive, 0 negative. See, interesting. You didn't go through this. Learn. You are not at all prepared for the test. I am sure you are not at all prepared. Just attending the class and reading for the timing and this. Okay? Delta surrounding will be 2 parts. Delta surrounding will do 2 parts. Source and sink is what? Tell me. First take a source. Surrounding. Q reversible by T. So what it is? What is the 2400 kilojoule? Opposite sign. Because surrounding, if it is system gets who gives surrounding this, so opposite sign. So minus, Intel minus Q process, minus Q surrounding, okay? So what is this? Tell me, what is this? Q process is it? Source, has source and sink both. Recall. It is source, surrounding the source. What is the process? What it leads? Minus 2400. So minus Q process, if you don't remember, but you say that it has given. So minus. What is the temperature surrounding? Tell me. 400. In the next case, it is maximum 800. So I consider the maximum. So what is this? Reject, system rejects. So it surrounding gets. So it is plus 1800 by 300. Considering the maximum value. Considering the maximum rejection. Considering the maximum rejection as claimed. Rejection of heat as claimed. as claimed. What is this? Plus, how much is it? Minus 6 plus 6 is 0. What is delta S inverse cycle? Cycle is what? 0 plus 0 is 0. That means it is a reversible cycle. Yes, what is the comment? It is a reversible cycle. Reversible cycle. Write that. You don't have to write so many things. Reversible cycle. But now we consider less than maximum. Then you will see reversible cycle is no. If you actually come and claim that it is a reversible cycle, so everyone knows. Before you come, I know. We know. If you say these are the values, these two values, ball, source and sink, and this will automatically 1800 for reversal. 6 times, 6 times. Automatically. That's why I say 6 times, 6 times. Automatically, we know. You don't have to claim anything. So it is a reversible cycle. So no complaint, but it is reversible. But supposedly he has actually come up with an irreversible one. My cycle. Obviously irreversible cycle. No one actually to operate irreversible cycle. So next, remove this. Next, star. Time up. Next, it is over. Next we consider less than rejection to the surrounding sink of less than maximum value. Of 1800. Quickly do this. Quickly. Less than, let us see. You say maximum. Oh, let us see what you do. Delta surround again, similarly as before. Delta system cycle, how much? Tell me, how much? Another cycle. It is cycle which is less than 1800, like 700, 1600, 1500. Anything less than 1800, it has rejected. Okay. So starting, delta system cycle is what? Delta surrounding cycle is what? Step by step. First one is as before, because taking heat from the source has not changed. That has not changed. About the rejection, sink part has changed. So it is over. So this is what? Tell me. One is minus 2400 Q process by 400. This part unchanged. But what has happened? What you write here? Maxima, less than maxima, I will consider. Means less than 1800. I don't give any number. 7600. Less than it will be fantastic. By what temperature? Temperature remaining the same. Same temperature, only less. What it is? Minus 6 plus less than. Minus 6 plus less than 6. Hence, delta S inverse cycle is negative. Hence, it is an impossible cycle. Improbable, impossible. Hence, the claim is false. Hence, it is an impossible cycle. This part, if it is less, impossible. Let's stop here today. But actually, I need 15 minutes. Can you give me 10 minutes next day? Not today. You are busy now. Not today. After I discuss the question paper, Monday what time? Okay. With these words, thank you very much. Okay, I will meet you in the next class. Okay, the remaining part I'll discuss your question paper, second class test next 2 or 3 days. Next Monday actually. Let us see.